Right, welcome once more to our video tutorial. This time we're going to look at logic gates, the inverter and not AND. In other words, the NOT gate and the NAND gate. The presenter is still me, Chigomana, MD. Right, the inverter. Now, what is the inverter? The inverter is a logic device that only has one input and one output. Now, the schematic symbol for this device is this one. Right, the inverter performs the logic function called inversion or complementation, which means it changes the logic level applied to its input to the opposite logic level at its output. Now, because it does not have at least two input links, it is technically not a gate. Therefore, the inverter is also referred to as a NOT gate. Now let us go to the truth table of the inverter. Right, check what I'm going to do here. I'm going to place the cursor over each row of the truth table so that you may observe the changes in input and output states of the gate. Look, when the input is 1, right, if you can just check right, when the input is 1, if you can just check here, the output is 0. When the input is 0, the output is 1. That is basically what the inverter does. Remember, the other name for the inverter is the NOT gate. And in our syllabus, we're going to continually refer to it as the NOT gate. Let us go to the illustration. Now, this circuit can be used to illustrate the operation of the inverter. Now, the switch represents the input and the light bulb represents the output. Now, if the switch is placed in an open position, it represents a logic 0. And when it is in a closed position, it represents a logic 1. When the light bulb is on, it represents a logic 1. And when it is off, it represents a logic 0. Now, if the switch is open, all of the current flows through the lamp and turns it on. Can you see? This is a little bit funny. If the switch is open, all of the current flows through the lamp and turns it on. If the switch is closed, it shuts out the lamp, preventing it from turning on. Now let us look at the Boolean equation. Right, the inverter operation can also be expressed by a Boolean algebra equation. This is the equation that we are talking about. A complement bar, also called an overbar, is placed over the assigned input letter. Now this is what we call the complement bar. The expression is read as x is equal to not a, which simply means that the output state is opposite of the logic state applied to the input. What is the application of the NOT gate or the inverter? Right. Right, the logic state is 0 and the output is 1. Right, the logic state is 1 and the output is off. Let me switch the switch. You must just observe what is happening here. Right, the input is 0, but the output is 1. Right, the input is 1, but the output is 0. Right, let us go to the NAND gate. Definition. The NAND gate is a logic device that has two or more inputs and one output. Now this is the schematic symbol for a 3-input NAND gate. The NAND gate produces a logic 0 at its output only when all of the inputs are logic 1. A logic 1 is produced when any of the inputs are low. Let me repeat this for the sake of effect. The NAND gate produces a logic 0 at its output only when all of the inputs are logic 1. A logic 1 is produced when any of the inputs are low. The truth table. Right, this is the truth table of the NAND gate. Right, all inputs are off, but the output is 1. Right, that is basically what you see. When all the inputs are 1, the output is 0. But when all the inputs are 0, the output is 1. Which means that the NAND gate is the opposite of the AND gate. Now you must know how to draw the diagram and how to interpret it. Now let us go to the illustration. Now this circuit can be used to illustrate the operation of the NAND gate. 3 switches labeled A, B, and C are used to represent the inputs, and a light bulb labeled X is used to represent the output. An open switch represents a logic 0, and a closed switch represents a logic 1. When the light bulb is on, it represents a logic 1. When it is off, it represents a logic 0. Let me repeat this. When the light bulb is on, it represents a logic 1. When it is off, it represents a logic 0. The only time the bulb is off is when all the input switches are in the 1 state, closed position. That is the only time when the bulb will be off. Which means that the bulb will be on when all the input switches are off. Let us look at the Boolean equation. Right, the NAND gate operation can also be expressed by a Boolean algebra equation, and for the 3-input NAND gate just described, the equation is as follows: X is equals to A and B and C, and there is an overbar. Now the expression is the same as the AND gate with an overbar above the entire portion of the equation representing the input. Let me repeat. The expression is the same as the AND gate with an overbar above the entire portion of the equation representing the input. This equation reads X equals A and B and C not, which simply means that the output of the gate is not a logic 1 when A and B and C inputs are all in their 1 state. Let us go to the application. Now, the diagram shows how an AND gate is used to activate a dashboard light if any doors of an automobile are left ajar. A door that is securely shut will open a normally closed push button switch and apply a logic 1 to the gate input. The push button will close when the door opens and applies a logic 0 to the gate. Right, let us do this. I'm going to open each door. Now this is the door that I'm going to open. Right, when the door is open, the light is on. But surprisingly, the input is off. In other words, this input tells us that our door is off. Now, when our door is off, if we are using the NAND gate, it means the light must be on in order to inform us that one of the doors is on. It's off, it's open. Right, let me close this door. Let me open this one. When I open this one, it will the logic will be 0, but the output will be 1, so the light will be on. Right, let me close this one. Let me open the left rear. Right, immediately when I open it, our logic gates indicate is 0. Our input indicate is 0. Why? Because the door is open. But because we are using the NAND gate, that is when the light is supposed to be on. Right, let me close this and open this door. Right, immediately when I open this door, it activates, the input becomes a 0. But because we are using the NAND gate, the light is on. Right, I think you understood how the NAND gate works. In other words, when using the NAND gate, the output becomes high. The output becomes high only when the inputs are low. I hope you understood how the NAND gate works. Thank you. Let us meet in our next lessons.